Hello, you are welcome to this channel, Research Plus. In this channel, I provide you with AI approaches to research analysis, interpretation, and reporting. If this is your first time of coming to this channel, please subscribe to this channel, and anytime I come up with new quality content video like this, you'll be the first person to be notified. Thank you. Let's take our today's class, and God bless you. You are welcome to class today, and in our tutorial class today we are going to take a topic: what is test of normality in research data sets? A test of normality is a statistical procedure used to determine whether a given data set follows a normal distribution. The normal distribution, also known as Quotient distributions or a bell curve, it is a symmetrical probability distribution that is characterized by its bell-shaped curve. It is widely used in statistics because many natural phenomena tend to follow these distributions. Probability distribution curve, known as bell curve. This diagram that I'm showing you describes the live phenomenon. In a live phenomenon situation, there are people that underperform. Their performance is seriously underperformance. There are some that are below expectation. There are some that meet the expectations. There are some that are above expectation, and there are some are excellent. So this is a real life situation. The distribution of people in the entire globe fall within this range. So anything you are going to do will fall within. So the situations of life move in a bell curve shape. So this bell curve is divided into two major parts, the left and the right hand, the right part. So from what you are seeing from this diagram, you will discover that from the meet expectations, which is the mean value, that is here, this place that you are seeing is the mean. So anything that falls within this side, left hand side, is a negative, and anyone that falls to this side is a positive. So while we are trying to explain the normality of a data, we use this bell curve to show to you that if a distribution of your data shape looks like this, it means that your data is normally distributed. I hope you are getting value from this video as we continue. Having seen the normal bell curve, there is a concept that is used to explain this bell curve of probability curve. It's called skewness and kurtosis. What is skewness and kurtosis? These are informative in assessing the shape of a distribution. Skewness is a measure of asymmetry of probability distribution of a real value random variables about its means. In a simpler term, it indicates whether the data are skewed to the left, which is called negative skewed. Skewed to the right is called positively skewed, or symmetrically distributed around the mean. Skewness is typically measured using a skewness coefficient, which can be calculated from the moment of the distributions. So from this diagram that you are seeing, this very one is symmetric, meaning that the distribution is a normal distribution. You will now see that this is the mean at the center, and this other one that you are seeing is asymmetric. Asymmetric simply explain that this data is concentrated at one side, and from what we are seeing from here, the moment it is concentrated at the right hand side, it is called a positive skewness. So this is what you are saying. So from positive and negative skewness, this diagram below is showing exactly what I am explaining to you. The positive skewness is from the right hand, and the negative is from the left hand, which is the mean, the mode. So in this diagram, we are trying to study the shape of our normal distribution curve. So it is with this concept that when we are running our analysis in SPSS, mean value is a king in SPSS. So sit down as we continue to unveil higher thing concerning SPSS analysis. I hope you are getting value from this video. Let's continue from this place and move forward. As a matter of fact and emphasis, kurtosis is a measure of tailness of the distribution of a real value random variables. It describes the sharpness of the peak of a distribution relative to a normal distribution. A distribution with a high kurtosis has heavy tails and a sharp peak, while a distribution with a low kurtosis has a lighter tail and a flatter peak. Kurtosis is typically measured using the kurtosis coefficient, which can be calculated from the moment of distributions. Just like I told you previously that running SPSS analysis, mean value is a key. And I am going to show you at the course of analysis in SPSS these kurtosis coefficients and how we can take decision around it. All that I've told you from the previous lessons, from our previous discussion, is to prepare our mind to this particular place where we are going to talk on the test of normality / decision rule. If a data is normally distributed, for you to run analysis in SPSS, this is the basic fundamental theory behind it. You cannot run SPSS analysis without checking these parameters that we have just started with. Your data has to be normally distributed, and for you to ascertain the normality of your data, you need some information, you need some indices to hold onto. That was why we look onto skewness and kurtosis, which form the basis of our normal distribution curve. So, in this place, we are going to continue. If the data is normally distributed, the following relevant parametric tests can be used. For example, if your data is normally distributed, you are free to do what is called linear regression analysis. And this linear regression analysis is of different type. We have simple linear regression, We have multiple linear regression. We have hierarchical linear regression. You can decide to choose correlation analysis. Meanwhile, let me say something before I forgot. When you are running regression using SPSS, sometimes the regression will automatically run correlation analysis for you. But meanwhile, you have the option of running correlation analysis. And correlation analysis is of two types. We have peer-sum correlation, if the data are normally distributed, or Spearman rank correlation, if the data are not normally. It is a crime in academic for you to run a research analysis without checking the reliability of your instruments. So what is reliability test in SPSS? Reliability test in SPSS, it is a test of internal consistency of an instrument. And as I have said, that we have so many reliability tests in SPSS, but I'm so much interested in Cromba alpha reliability coefficient. So this is what I'm going to concentrate on this tutorial. And I have made a provision of Cromba alpha coefficient reliability table benchmark for accepting or rejecting the reliability of any construct as follows. So, by the table, anytime you calculate your reliability coefficients and you came up with a value that is less than 0.5, what this less than 0.5, as you are seeing me marking it here, means is that your coefficient is unacceptable. And peradventure you did your calculations and you came up with your Cromba alpha coefficient reliability value as 0, that range from 0.5 to 0.6. It is a poor reliability coefficient value. And if you came up with a value that ranges between 0.6 to 0.7, it is a questionable coefficient. And if you calculate your reliability and you came up with a reliability value that range between 0.7 to 0.8, it is an acceptable coefficient. And that is not yet the best, if you calculate your reliability and you came up with 0.8 to 0.9, it is a good reliability. And if you came up with any calculations and your coefficient has given you 0.9 and above, it is an excellent reliability coefficient. So it is on this benchmark that you can run your regression in SPSS or any other regression package. So sit down as we check our data to trace the reliability coefficients of it in order for us to make a decision whether we are going to run a regression, whether we are going to use parametric test or we are going to use a non-parametric test in order to run our regression.